y1 minus y0 over x1 minus x0, and along with this there is another term x2 minus x0 and plus a2 x2 minus x0 and x2 minus x1. So now you can see we have a bit lengthier polynomial and a bit more complicated formation here, and the task is to separate a2. So here we are now going to separate it. In order to separate it, I keep all these, I keep the a2 terms on one side and shifting all the others on the other side. Keeping this on the one side, that gives you a2 x2 minus x0 inside x2 minus x1. This is on the left side, and whenever I shift it to this side, this becomes equals to y2 minus y0. If I keep it as it is in a single bracket, minus this plus sign will change whenever you shift it on the left. So this gives you y1 minus y0 over x1 minus x0 and x2 minus x0. So this is another format here. Okay, after doing this, now I'm transferring these two terms to the right hand side, and whenever you shift them to the right side, so these are going to divide this term as well as this. So here we get a2 is equals to y2 minus y0 over x2 minus x0, and the second term is x2 minus x1. Okay, the first term is there, and now on dividing the second term we get x2 minus x0 will drop down with this one. In the numerator there is y1 minus y0 whole divided by this term x1 minus x0, and from here this term as well. Okay, now you can see here we have a bit more simplified form of the previous polynomial. Now we can further simplify it. If you remember, I had just given you the instructions that whenever we go from one level to the other, we assign an increment in the form of h. So here you can see, moving from x0 to x1, there is h there. So this means x1 minus x0 can be equals to h. So here this you can see here x minus x1 can be replaced by h here. Similarly, x2 to x1, if this is x2, so there is another increment, and the difference of these two can also be replaced by h only. And in moving from x0 to x2, from this point to this point, we are giving 2 times increment of h. So accordingly, I am going to replace all these terms with h. So y2 minus y0, this is equals to 2 times h, and this is 1 time h, and minus, let me erase it from here. Okay, now you can see here on putting the values of h here, we can replace it y1 minus y0 whole divided. This is equals to h, and this quantity is also equals to h. So here you can see the LCM of these two terms is equals to 2 times h square. On taking the LCM and simplifying, we get y2 minus y0 minus 2 will come from here, and it will take the product with these terms, 2y1 along with this minus sign, it changes. So 2y0 whole divided by 2 times h square. Now this can further be simplified, and we get y2 minus 2y1 from here, and these two will give you plus y0 whole divided by 2h square. And this is your a2. And from here you can see, if you pay a bit concentration on this term only in the numerator, whenever we were talking about the operators, so this was equivalent to, if you remember, del 2 times y0 over 2 times h square. If you remember the previous two unknown which we have obtained, A0 was equals to Y0, A1 was equals to del Y0 over H. If I write in the form of 1 times 1 factorial here, so similarly I can replace it by 2 factorial from here. Now you can see the value of A2 is equals to del 2 times Y0 over 2 factorial over H square. If I ask you to write down the similar result, kind of result for the next unknown, which is of course A3. So we can write down directly the result without doing any other calculations. So the result can be written as, if I write down once again here, A0 is equals to Y0, A1 is equals to del Y0 over H 1 factorial times H, A2 is equals to del 2Y0 over 2 factorial times H square. And looking at this pattern, we can write down the next result on the same pattern. So the result for A3 will be equals to del 3 times Y0 over 3 factorial times H cube. And we can proceed on the same lines, and the result for nth term can be written as del ny0 over n factorial times h raised by n. So here you can see we succeed in finding all the unknown involved into the polynomial. If you remember, the initial polynomial was a0 plus a1 and so on. Now we got all these unknown, and the next step is to substitute back these unknown into your main polynomial. So keeping all these in your mind, I am putting these into the original polynomial. Okay, so just due to the shortage of the space, I am raising it from here and putting the values back into the main polynomial. So the first term on the left side is for the nth degree polynomial, and we can show it simple. Instead of writing yn of x, I write it in the form of y. So the result takes the form y is equals to a0. A0 was, which we have just calculated, is equals to y0. So I have replaced a0 by y0 plus a1. A1 is del y0 over 1 factorial times h along with x minus x0. The next term will be plus del 2y0 over 2 factorial times h square, x minus x0 and x minus x1. Similarly, the next term will be del 3y0 over 3 factorial times h cubes, x minus x0, x minus x1 and x minus x2. And we can proceed on the same lines, and the last term can be written as del ny0 over n factorial times hn, x minus x0, x minus x1 and so on, x minus xn minus 1. So after substitution of the unknown involved in the polynomial, I succeed in finding this polynomial. Now this result, of course this is the interpolation formula, but we are going to make a bit more changes here to make this formula in the more compact form. So the changes which we are going to introduce here are, so we are now putting x is equals to x0 plus ph. So I am using this substitution, and this will make your result a bit more simple form, and that will be helpful to keep the formula in your memory. So from here we can further write it as x minus x0 is equals to ph. Now you can see here x minus x0